We propose a pipeline for holistic 3D scene understanding from a single image with implicit representation. From only a single image, we aim to jointly estimate room layout, object poses as oriented bounding boxes, and object meshes, thus achieving semantic understanding and reconstruction of the scene. Previous works like Total 3D Understanding propose to solve the problem following a box-in-the-box manner, which represents the scene as object meshes with oriented bounding boxes placed in a cuboid room layout, and decompose the task in a bottom-up way into layout estimation, camera pose estimation, 2D detection, object pose estimation, and object reconstruction. However, existing works still struggle on understanding and utilizing the scene context like humans to better arrange the placement of objects. For example, it's reasonable to infer from the context that the heavily occluded sofa here should be facing towards the table in the center of the room, instead of the wrong orientation estimated by Total 3D Understanding as shown on the right. Also, it is not well considered on how to avoid the intersection between objects in the final scene reconstruction. Last problem is that due to the use of the mesh representation by the latest single object reconstruction method, the output shape is often low quality and low poly. To tackle the first problem of context understanding, many other works have proposed to use GCN. However, by solely relying on GCN in the task of scene understanding, the problems of object intersection and shape quality remains unsolved, not to mention that even for a model as powerful as GCN, rich features are still required to provide shape priors and context information. To solve the above problems, we turn to implicit representation. Our motivation is that implicit representations like signed distance function can naturally represent whether a point is inside an object and provide a gradient to push it away from the object, which can be exploited to construct a physical violation loss to penalize intersection. Moreover, the latest local deep implicit functions, or LDIF, provides a compact while precise method to decode object shapes from a latent vector by incorporating implicit and structured representation, which can further improve the results of single object reconstruction, and to provide more structured shape priors for GCN. Therefore, we propose to incorporate GCN with implicit representation to solve the above problems. Our pipeline consists of two stages, that is, the initial estimation stage and the refinement stage. In the initial estimation stage, from a single image, we first predict the initial cuboid room layout, and the 2D object detection. Then from each image crop we estimate the initial pose, and embed an implicit shape code for corresponding object. In the refinement stage, we model layout and objects as a graph to understand the scene context and refine the initial estimation with a graph convolutional network. Respectively, the above initial estimations, features, and shape codes are concatenated and embedded into node representations, to be further updated with message passing. The updated representations are later decoded into residuals to refine the initial estimation. The refined poses are then incorporated with the object shapes decoded from shape codes with LDIF, to get the final reconstruction of the whole scene. During training, upon all the losses used in Total 3D Understanding including direct supervision on network outputs, we further propose a physical violation loss based on the insight that objects should not intersect, to penalize the points inside both adjacent objects. Here we show our results. In quantitative comparison, our single object reconstruction method produces the most accurate 3D shape compared to other methods, yielding the lowest mean chamfer distance. In 3D scene understanding, we compare to the state-of-the-art methods from aspects including 3D object detection, layout estimation, and camera pose prediction. The results show significant improvement especially on 3D object detection. Here we compare our results qualitatively with the state-of-the-art. For final scene reconstruction, our model has fewer flying objects, better object poses, less intersection, and finer meshes. For single object reconstruction, our method produces 3D shapes with correct topology, smooth surface, and fine-grained details, which clearly shows the advantage of the deep implicit representation. To verify the effectiveness of the proposed components, we carry out ablation study by disabling each of them and comparing on layout IOU and 3D object detection MAP. The study shows that each component contributes to the final improvement of both layout and 3D object detection, that is GCN, two features from LDIF for GCN, and physical violation loss. Also, further qualitative comparison shows that physical violation loss does reduce object intersection. In summary, we present a two-stage single-image holistic 3D scene understanding system based on deep implicit representation. We also propose a local implicit shape embedding network based on LDIF, which extracts latent shape information from a single image and leads to superior geometry accuracy. Furthermore, we propose a novel GCN-based scene context network to refine the object arrangement which well exploits the latent and implicit features. Finally, we propose a physical violation loss with the implicit representation that effectively prevents the object intersection. Our code, data, pre-trained models are available online. Thank you.